Hello, my name is Prateek Singh. I'm a student of the BSc Honours in Data Science and Artificial Intelligence online degree program at IIT Guwahati. This is my term project submission for trimester 8. The project I am presenting today is called Neural Style Fusion, an implementation of the neural style transfer algorithm using a deep convolutional neural network called VGG19. So, what problem are we solving? The central question is, can a neural network learn to paint? Given two images, a content image, which is a regular photograph, and a style image, which is, let's suppose, a painting, can we generate a new image that looks like the photograph was painted in that artistic style? The answer is yes, and the technique is called as neural style transfer. The three ingredients which we use are the content image, which has the structure that we need to preserve, the style image, which is the aesthetic which we need to borrow to produce our output, and the generated image, which is the stylized output. The formula is known as C plus S, which gives us the generated image G. Now, let's talk about the learning journey. The project was the destination of a step by step learning journey. I began with deep learning foundations, ANNs, activation functions, backpropagation. Then I built a two layer neural network from scratch in NumPy to classify the MNIST digits. Next, I rebuilt it in PyTorch and GPU acceleration. I then studied CNN architectures, how filters detect edges and textures, and the VGG19 architecture with 19 trainable layers. All of that led to the final step, implementing neural style transfer. The tools I used are Python as the core language, PyTorch for deep learning, which handles automatic differentiations and tensor operations, VGG19 as the pre-trained CNN, used solely as a fixed feature extractor, Torch Vision for pre-trained weights and image transforms, Pillow for image loading and saving, NumPy for numerical operations, Flask to build the web interface, allowing anyone to run the algorithm in a browser without writing any code. The key insight over here is a pre-trained VGG network has learned to represent images at different levels. Early layers capture textures and edges. These encode style. Deeper layer captures objects and shapes. These encode the content of the image. Convolution 402 is the content layer, and convolution 1 cross 1, convolution 2 1, and convolution 3 1, 4 1, and 5 1 are the style layers using gram matrices. Content loss over here is the mean square difference of feature maps at convolution 4.2. Style loss over here is the difference of gram matrices across the 5 layers. Total loss is alpha into J content and J style. Adam Optimizer updates only the pixels of the G to minimize this loss. Three key code sections over here are: first is the get features, which passes an image through the VGG19 and captures outputs at named layers. These feature maps are what we compare. Second is the gram matrix, which reshapes the feature tensor and computes the matrix product with its transpose. This encodes which feature activates together. That is known as the artistic style. Third is the optimization loop. For each iteration, which extract features from the G, compute content and style loss, sum with alpha and beta, call backward, call optimizations, and then updates the pixels of the G. This is what the entire algorithm is and how it works. Now let us look at the generated results. I have generated four results. First one is a building sky cityscape, which is an IIT Guwahati landscape using a Van Gogh starry night picture or a painting. It has swirling brushstroke textures applied over the architecture. Second one is the result of a lion portrait plus a mosaic pattern. It has a mosaic effect and a face structure of the lion is preserved. Third one is the owl portrait plus an orange swirl abstract painting. Warm swirling textures and eyes and the beak is recognizable. The fourth result is the NYC Brooklyn Bridge plus an oil painting combined for the styling. City lights blended with the paint, as you can see. These results confirm the algorithm successfully transfers artistic styles while preserving the content structure. I built a complete Flask web interface with four features: drag and drop upload for content and style images, live progress bar polling the server every second showing current iterations and the current losses, adjustable sliders for alpha, beta iterations and image size, one click download for the final image. The backend runs style transfer in a background thread, so the UI stays responsive. Deploy it publicly on the Hugging Face space using Docker, and it is accessible from any browser worldwide anytime. Now let me show you the web interface I built for this project. This is a Flask-based web application deployed live on the Hugging Face spaces, which means anyone with a browser can use it without any installations. Now, this interface has two upload zones. The left one is for your content image and the right one is for the style image. You can either click to browse or simply drag and drop your images directly onto these zones. So I will upload a photo as my content image, and this is the structure which I want to preserve. So I'll use this image as my content image, and now I will also select a style image, and this is a image from where the artistic character comes out. So I'll select this mosaic pattern over here. Now, we can look over here at these pointers. So the alpha or the content weight, this determines how much of the original photo structure is to be preserved. So by default, it is selected to 100. The beta controls the style weights, which means the how long or how good the artistic effect you want over here. And then comes our iterations. The iteration controls how long the optimization runs. The more optimizations or the more iterations means a more smoother result. Over here, this is the image size. Image size controls the resolutions of our output. I have kept these all values at my default, which is alpha is at 100, the style weight is at beta, the number of iterations are selected to be 300, and the image size is given to 56 pixels. This gives a good quality balance between speed and also quality. Now over here, I will click on the generate stylized image, and as I click over here, you can see the progress bar updating in real time. So this is the front end pulling the backends every second, showing the current iteration number and the loss value as it decreases. As you can see, the iteration currently is increasing and the loss is optimizing. And the algorithm running on the server right now is passing both the images from the VGG19 computing and the gram matrices for style, and also the Adam optimizer to update the pixels of the generated image. And so here we go, the stylized image is ready, and you can see the content structure of the original photo combined with the texture and the color palette of the style painting. And I can also download the results directly from the browser with one click. This whole interface from drag and drop, upload to the live progress bar to the REST API backend was built entirely by me as a part of this project, and is live at the link shown on the screen. Now let's look over the key observations and results. The key observations from the experiments are that the higher alpha preserves more content structure and lower alpha makes output more abstract. Whereas knowing the higher beta amplifies the style effect too, and the high losses the content. 300 to 500 iterations gives a good quality to time balance on the CPU. Alpha to beta ratio of 1 is to zero point 0.4 is what worked well across all of my test domains. Strong textures like the Van Gogh painting and the mosaic transfers were more visible and were more subtle. And also, the image size of 256 pixels took 5 to 8 minutes on the CPU, whereas on generating a 512 pixel image, it took around three times more longer, which is approximately 10 to 15 minutes. It totally depends on the speed of your CPU, or also if you're using a GPU, then it would produce much quicker results. Now, to wrap up, this project implemented neural style transfer from the ground up using the theory, code, and real artistic results. A fully functional web interface was deployed publicly on the Hugging Face spaces, and the key takeaways from this project are the gram matrices are the heart of the style transfer. They encode the texture independently from the content image. The alpha to beta ratio is the most important creative control over here. The future works may contain a fast NST for real-time results or a video style transfer and also a custom style network. Thank you.